Hi there, my name is Dimitris, and in this video, we'll talk about the probability of an event. Previously, we have mentioned what a probability experiment is and how we can find its universal set. Now, we'll see how we can utilize both these concepts. To begin with, allow me to give you a short definition. In general, probability of an event refers to the likelihood or chance that this particular event will occur, will happen. In mathematics, probability is a numerical measure of this likelihood, of this chance, often expressed as a number between 0 and 1, where 0 represents impossibility, no chance of that event happening, and 1 represents certainty. In theory now, and more formally, the probability of an event is defined as the ratio of the number of favorable outcomes to the total number of possible outcomes in a given experiment or random process. Once again, the probability is a ratio, a quotient, of the number of favorable outcomes of that event over the total number of possible outcomes. So most likely, we will be working with the cardinality of that event, the probability of which we need to calculate, and the cardinality of the universal set. So the theoretical probability of, let's say, an event A, let me write the definition. The theoretical probability, assuming that we have the event A, its probability will be defined as the ratio of NA over N of U. Cardinality of that event over the cardinality of the universal set itself. Let's work some examples. Flipping a coin. Find the probability of getting heads. We have already seen that when flipping a coin, the universal set contains two outcomes, heads or tails. Assuming that our event A is the one where we need heads, I need heads, so this will simply contain the heads. The cardinality of U is 2, the cardinality of A is 1, so the probability of A would be 1 over 2, which makes sense. When we flip a coin, the probability of getting heads is 50%, 1/2. Example 2. Let's say that now we will flip 2 coins. So when flipping 2 coins, we know that the universal set would be heads, 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 tails, tails, heads, and tails, tails. We want to have at least 1 heads. This, and that is why universal set is important, because all outcomes are taken from it. At least 1 heads will include heads, 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 tails, and tails, heads. So the cardinality of U is 4, cardinality of A is 3, and therefore probability, which is defined as the cardinality of A over the cardinality of universal set, would be 3 over 4. Example number 3, throwing 2 dice. We have already seen that the universal set in this case is all 36 pairs of numbers formed by this. Let me write them. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and finally 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6, respectively. So, in total, its cardinality will be equal to 36. Now, let me define my event. I want the sum of faces is 7. And to find which of the outcomes satisfy this, I will go and search them through the universal set. A sum of 7 can be taken by this, 1, 6, by 2, 5, by 3, 4, by 4, 3, by 5, 2, and by 6, 1. So this set would include these pairs, 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1, which makes its cardinality equal to 6. So finally, the probability of that event would be its cardinality divided by the cardinality of the universal set. So it should be 6 out of 36, which means 1/6. And finally, let's see example 4. A class has 6 boys and 7 girls. A student is selected at random. So in this process, the universal set would have been each one of the class's students. So I will notate them as B1, B2, B3, B4, B5, B6, and G1, G2, G3, G4, G5, G6, and G7, which means that in total, there are 13 possible outcomes. The cardinality of the universal set is number 13. Now, let us define the event that we need. We need to select a girl, and this event is satisfied by any of these 7 girls, G1, G2, G3, G4, G5, G6, and G7. Therefore, the cardinality of that event A would be 7. And finally, we remember that we define the probability of an event as the ratio of that event's cardinality, the amount of favorable outcomes of that event, over the total possible outcomes of the entire probability experiment. So P of A would have been equal to N of A over N of U, which is equal to 7 over 13. And that was all. Remember that you should know from now on that given an event of a probability experiment, its probability, its theoretical probability, in my next video, we will discuss the differences between the theoretical probability and the experimental probability. But for now, for this, keep in mind that the theoretical probability is defined as the ratio of that event's cardinality over the universal set's cardinality. And that's it. For any questions that you might have regarding the content we just viewed, you are more than welcome to leave your comment below this video. As always, thank you for your time.